In this video, we will provide two examples of concepts we learned in class. One of them is regarding angular kinetics emphasizing angular inertia, and the other is friction. In order to conduct these two experiments, you will need a short bat, a long bat, soccer cleats, and climbing shoes. Throughout these concepts, we will be describing how angular inertia plays a role regarding bat sizes. In the friction scenario, we will be describing how soccer cleats provide better support when changing direction as compared to climbing shoes. In this picture, we can see that the short bat has a decreased length from the axis of rotation. This makes the mass distributed closer to the axis of rotation, thus making the shorter bat easier to rotate compared to the longer bat. Using the formula I equals mk squared, by increasing m, which is the mass, and k, the distance from the axis of rotation, the inertia will also increase. This increase will make the bat harder to rotate, or decreasing the angular acceleration. However, it will be able to transfer more momentum from the bat to the ball while utilizing slower angular acceleration. Using the same formula I equals mk squared, by decreasing m and k, the inertia will also decrease. The decrease will make the bat easier to rotate, or increasing the angular acceleration. However, it will transfer less momentum from the bat to the ball while utilizing faster angular acceleration.
In this experiment, we will be analyzing friction, but before we start, we have to know what friction is. Friction is a force that opposes motion between two surfaces that are in contact with another. Friction also has a formula. Static friction equals coefficient of friction times normal force. We'll be analyzing the friction between soccer cleats and climbing shoes and see what provides better support while changing direction. On this example, we can see our athlete switching direction with the climbing shoes. While he's switching direction, there's three forces being applied. One of them being force of friction to the right, the second one being the force to the left created by our athlete, and normal force. In other words, gravity. The moment he's switching direction, he loses static friction, and this is converted to kinetic friction. Since our athlete's kinetic friction is greater than the force of friction, he'll move. However, since he's using climbing shoes, these type of shoes do not provide good friction with the grass. We're going to see an example of a professional athlete switching direction. The moment our athlete switches direction, he loses synthetic friction, and this is converted to kinetic friction. Since the kinetic friction of our athlete is greater than the force of friction, he'll move. However, since he's using soccer cleats, he'll be able to move with no problem.